Let us learn about temperature or thermal stress. Now, first of all, we need to learn about what is meant by natural or free deformation. Now, when a particular body is heated, it expands. That is, the length of that particular body will be increased, and on cooling, it contracts. That means when we particular body is heated, it expands, that is the length of that body will increase, and on cooling it contracts. Cooling, it will contract, that means the length of that particular body will decrease. So the expansion of a body due to rise in temperature and contraction of a body due to fall in temperature is known as natural or free deformation. Okay, now what is meant by free or natural deformation? When a particular body is heated, it expands, and cooling, it contracts. Hence, the expansion of a particular body due to rise in temperature and contraction of a body due to fall in temperature is known as natural or free deformation. Okay, now if now here in this case, in case of the free deformation, there is no any temperature stress or strain are developed within the body. In case of, if there is a free or natural deformation, there is no temperature stress or strain are developed. Now here you can see the figure. Okay, now at one end is fixed, this is the metal bar. Okay, and when that body, when a material or when a metal bar is heated, then what happens, it expands. That means the length of that particular body, that is the delta L, is the free expansion. Here you can see here free expansion. Okay, and this is the free end. Now this is fixed end and this is free end. When the body is heated, in that case it expands, and it is expands like this, and that expansion is known as free expansion. Okay, and in this case temperature stress and strain will not be developed. Okay, याद रखें, फ्री डिफॉर्मेशन किसे कहते हैं, या फ्री एक्सपांशन किसे कहते हैं, या फ्री कॉन्ट्रैक्शन किसे कहते हैं? एक पर्टिकुलर बॉडी को जब हम हीट करते हैं तो उसकी लेंथ इंक्रीज होगी. कब? एक पर्टिकुलर बॉडी की फ्री एंड जो होगा फ्री एंड होगा, तो उसको हम क्या कहेंगे? एक तो क्या होगी, हीट किया तो एक्सपांशन बढ़ेगा, और कूलिंग किया तो उसका कॉन्ट्रैक्शन होगा, यानी उसकी लेंथ डिक्रीज हो जाएगी. ठीक है, अब यहाँ पे एक फिगर यहाँ पे हमने ड्रॉ की है, उसको आप देख सकते हैं. हियर वन एंड, यहाँ पे एक एंड फिक्स्ड है और अदर एंड फ्री है, तो यहाँ पे पर्टिकुलर बॉडी को हमने हीट किया तो उसकी लेंथ इंक्रीज हो जाएगी, तो उसको हम क्या कहेंगे? फ्री एक्सपांशन कहेंगे. ओके, एंड नाउ इफ द bar having a length capital L, and if we consider the alpha as a coefficient of linear expansion or contraction, and when it is heated through a temperature rise of T degree centigrade, it will expand naturally without any stress by a small change in length. Okay, यहाँ पे क्या होगा, पर्टिकुलर बार जिसकी लेंथ L है, अल्फ़ा कोएफिशिएंट ऑफ एक्सपांशन, और जब एक पर्टिकुलर टेम्परेचर से हमने उसको हीट किया एट T डिग्री सेंटीग्रेड, देन इट विल एक्सपांड्स. वो क्या होगी, उसकी लेंथ बढ़ जाएगी नेचुरली विदाउट एनी स्ट्रेस, उसमें कोई स्ट्रेस डेवलप नहीं होगा. बाय स्मॉल चेंज इन लेंथ, क्या होगा, चेंज इन लेंथ बढ़ जाएगी बस. तो यहाँ पे फ्री एक्सपांशन और नेचुरल डिफॉर्मेशन क्या होगा, डेल्टा L बिकम्स L अल्फा T. Okay, now here it is the product of length of that particular body, coefficient of expansion, and the temperature rise. Okay, now notice formula. Here we have considered capital L is the original length of that particular bar, alpha is the coefficient of linear expansion, or we can say linear contraction, and T becomes rise or fall in temperature. Got it? Next, then how temperature strain and strain is developed within the body? Now there is one condition. Okay, then look at this figure. Okay, now when a particular bar or metal bar is fixed at both ends rigidly, okay, and if that particular bar is heated, okay, in that case what will happen, the length will increase. Okay, now here you can see here, if a free expansion or contraction is resisted, now when the particular body is fixed at each end, what will happen, the expansion or contraction is prevented or resisted by fixing the bar at its ends rigidly. Then in such a case only temperature, strain and strain is developed into the metal bar. Now you can say any body when it is heated or cooling, but the condition is what, both ends are fixed, दो दोनों तरफ से एंड क्या है, फिक्स्ड हैं, ऐसे सिचुएशन में क्या होगा, एक्सपांशन को भी हमने प्रिवेंट किया है और कॉन्ट्रैक्शन को भी प्रिवेंट किया है, मतलब इंक्रीज लेंथ भी नहीं हो रही है और डिक्रीज को भी हमने क्या किया है, प्रिवेंट किया है. इन दैट केस व्हाट विल हैपन, इस केस में टेम्परेचर स्ट्रेन और टेम्परेचर स्ट्रेसेस डेवलप्ड हो गए. Okay, now in this way we can find the temperature, stress and strain. Then how to find then temperature, strain? Okay, now for this purpose use this formula. Now we know strain becomes change in length upon original length. Okay, now using this concept we will directly use here free expansion, that is the temperature strain we denoted as ET, and free expansion upon original length, as we know free expansion is delta L and capital L is the original length, but free expansion is determined by using this formula L alpha T. Now listen, free expansion or free contraction, it is use this formula, for that purpose use this formula, free expansion होगा या contraction होगा, यही formula आपको use करना है, delta L is equal to L alpha T. Okay, now in this case alpha is the coefficient of linear expansion or contraction and T becomes rise in temperature, that is the temperature strain becomes alpha T. Okay, now in this case one important notification, note it down. Now if the free expansion due to rise in temperature is prevented, यहाँ पे याद रखें, अगर फ्री एक्सपांशन टेम्परेचर राइज होने की वजह से हमने क्या किया, उसको प्रिवेंट किया, इन दिस केस कॉम्प्रेसिव टेम्परेचर स्ट्रेन इज डेवलप्ड, वाइस वर्सा होता है. ठीक है, मतलब टेम्परेचर राइज किया, क्या होगा, टेम्परेचर राइज करने के बाद ये क्या होगा, यहाँ पे क्या होगा, एक्सपांड होने को देखेगा, लेकिन यहाँ पे क्या है, दोनों एंड फिक्स्ड है. ठीक है, एक्सपांड होने को देखेगा, लेकिन इंटरनल मटेरियल क्या होगा, उसको रेजिस्ट करने के लिए देखेगा. तो यहाँ पे मटेरियल मेटल बार में जो स्ट्रेन डेवलप होगा उसको क्या कहेंगे हम, कॉम्प्रेसिव स्ट्रेन डेवलप होगा. ओके, गॉट इट. नेक्स्ट, इफ फ्री कॉन्ट्रैक्शन ड्यू टू फॉल इन टेम्परेचर, टेम्परेचर कम होने की वजह से मेटल बार में जो लेंथ डिक्रीज होता है, अगर वो प्रिवेंट किया, इन सच अ केस टेंसाइल टेम्परेचर स्ट्रेन इज डेवलप्ड. इन दैट केस व्हाट विल हैपन, tensile temperature strain will develop. For example, if a particular body is prevented contraction, okay, what will happen, it becomes contra, यहाँ पे क्या होगा, टेम्परेचर कम होने की वजह से उसकी लेंथ डिक्रीज होने को देखेंगी ये, लेकिन यहाँ पे क्या होगा, यहाँ पे फिक्स है, तो यहाँ पे जो स्ट्रेस डेवलप्ड हो गए वो स्ट्रेन डेवलप होगा, तो उसको टेम्परेचर स्ट्रेन कहा जाएगा, सॉरी टेंसाइल टेम्परेचर स्ट्रेन कहा जाएगा. गॉट इट. नाउ हियर द नेक्स्ट स्टेप, टेम्परेचर स्ट्रेस we denoted as it is sigma t, but we know modulus of elasticity is equal to stress upon strain. Then in this case we will consider modulus of elasticity of a particular bar is equal to temperature stress upon temperature strain, we denoted as sigma t upon Et. Now therefore sigma t becomes E, capital E small et, therefore it becomes, as we know, Et, that is the temperature strain is equal to alpha t, we put it as here, then we will get the formula sigma t is equal to E alpha t. Okay, now here E becomes the modulus of elasticity sometimes it is called as Young's modulus. Alpha is the coefficient of linear expansion or contraction, and T becomes rise or fall in temperature. Now here again note it down, if free expansion due to rise in temperature is prevented, then in that case compressive temperature strain is developed, stress is developed. Okay, and if free contraction due to fall in temperature is prevented, then in such a case tensile temperature stress is developed, vice versa. Rise in temperature, compressive stress, fall in temperature, tensile temperature stress. Okay, now next case, then how to find the force exerted by rigid support to prevent free expansion. मतलब फ्री एक्सपांशन को प्रिवेंट करने के लिए जो फोर्स एक्सर्टेड होता है वो कितना लगेगा, ठीक है. तो इन दैट केस वी इफ यू कंसिडर द कैपिटल P एज अ फोर्स exerted by the rigid support, then in that case we already know stress is equal to force upon area. In this case we need to determine P, then we will convert it into P is equal to alpha into sigma into A, then P becomes sigma T A, but we know sigma T is the E alpha T, we have already determined in the last step. Okay, therefore P becomes E alpha T into A. Here A is the cross sectional area, P becomes the force exerted by fixed rigid support, alpha is you know coefficient of linear expansion or contraction, T is the rise or fall in temperature, and E becomes the Young's modulus. Okay, now for important terms, when we need to determine the problems, we need to remember these things, that is free expansion or contraction, or we can say free deformation. E delta L is equal to L alpha T, and the unit of that particular thing is mm. Temperature strain is denoted by Et, and it is determined by alpha T, where alpha is the linear coefficient of expansion or contraction, and T is the rise or fall in temperature. Now strain has no unit. Then temperature stress, and it is denoted by sigma T E alpha T, where E is the modulus of elasticity, alpha is the coefficient of temperature, rise in coefficient of linear expansion or contraction, and T is the rise or fall in temperature, and unit is Newton per mm square. And the last, force or load exerted by the fixed support, it is denoted by capital P, and it is determined by the formula E alpha T into A. Okay, and the unit of that particular thing is Newton or kilonewton. Okay, in this way we can find the temperature stress and temperature strain in the particular body. Okay, thank you.